In 2010, the world witnessed a catastrophic earthquake of magnitude of about 7 on the Richter scale that shook Haiti to its core. The quake struck at 5 p.m. local time, which is about 10 p.m. UTC, on Tuesday, 12th of January, near the town of Léogâne, approximately 25 kilometers or 16 miles west of Port-au-Prince, the capital of Haiti. The seismic event unleashed a series of 52 aftershocks, measuring 4.5 or greater on the Richter scale, turning the affected region into a widespread disaster zone that left millions of people reeling in shock and desperation. The impact of this disaster was truly unimaginable. The death toll ranged from about 100,000 to about 160,000 people, and the aftermath of this earthquake caused the collapse or severe damage of 250,000 residences and 30,000 commercial buildings, leaving countless people homeless and in dire need of aid. The scale of this tragedy was unparalleled, and its effects are still felt in Haiti to this day. In order to understand what exactly caused the earthquake in Haiti, we need to know why they occur in the first place. Earthquakes are caused by the movement of faults, which are the boundaries between tectonic plates. As the plates move past each other, they tend to create stress along the fault, which builds up over time. Eventually, the stress becomes so great due to various factors such as movement of fluids within the rocks, the overburden of the neighboring rocks, and sometimes even the pressure and temperature of magma. And this potential energy is suddenly released in the form of seismic waves. These seismic waves, also known as P waves and S waves, travel throughout the earth and can be detected by seismic stations around the world. By analyzing the data from these stations, scientists or geologists can determine the magnitude of the earthquake, which is the measure of the energy released during the event. The magnitude of the earthquake is based on a scale known as the Richter scale, and the Richter scale is named after the American seismologist Charles Richter. It is a logarithmic scale that measures the magnitude or the strength of an earthquake. The magnitude is calculated based on the amplitude of the seismic waves recorded by seismometers, which are basically the instruments that detect and measure ground motion during an earthquake. The Richter scale ranges from 0 to 10, and each whole number increases on the scale represents a 10-fold increase in the amplitude of the seismic waves and a 32-fold increase in the energy released by the earthquake. For example, an earthquake with a magnitude of 5 releases 32 times more energy than the one with a magnitude of 4. It is really important to note that the Richter scale is not a linear scale, meaning that an earthquake with a magnitude of 6 is not simply twice as powerful as an earthquake with a magnitude of 3. Each increase on the scale represents a significant increase in the energy released and the potential damage caused by the earthquake. Just to give you an example and some reference, the video that you see right now was captured by a CCTV camera in Haiti. This location is somewhere in Port-au-Prince, and the distance from the epicenter is about 25 to 30 kilometers. Now, if you watch the video carefully, you see that the telephone poles are standing whereas the buildings are collapsing. This is because the intensity of the earthquake decreases as you move further away from the hypocenter. An even more simplistic example would be to imagine yourself in a dark room with a single light bulb or maybe even a flashlight. As you move away from the light source, the brightness of this light gradually fades away. The point at which the light emanates from is known as the hypocenter, whereas the section of the room illuminated by the light source is known as the intensity. It is really important to differentiate between intensity and magnitude. Intensity signifies the strength of an earthquake, whereas the magnitude indicates how big the earthquake was or the size of the earthquake. Now let's come back to the present and take a look at where Haiti is located. Okay. So we know that the epicenter of the earthquake is located at Léogâne. If we take a closer look at the active tectonics in this region, we can see that the Caribbean plate and the North American plate slide past each other. The Caribbean plate moves east, whereas the North American plate moves west. Please keep in mind that this is the relative motion of these plates. Due to the sliding, it creates a major fault zone in this region known as the Enriquillo Plantain Garden fault system. Let's just call this EPG fault system for now. This fault system consists of active strike-slip faults. For those that don't know, strike-slip faults are faults in which rock mass is displaced mainly in a horizontal direction parallel to the line of the fault. So as you can see, Haiti lies in between of these plate motions and is surrounded by active faults. Also, the largest fault system, EPG, lies quite close to Haiti. So any sort of movement along this fault would cause tremendous earthquakes. So you must be thinking that this is what caused the 2010 earthquake in Haiti. Well, you're not wrong for assuming that. I also thought the same when I was researching about this topic. But this is actually incorrect. This is where things get interesting. Let me explain. After the earthquake struck in Haiti, every researcher assumed that it was a result of movement along the EPG fault zone. However, a team of geologists, geophysicists, and engineers arrived at the scene after the earthquake. And after carrying out several certain tests, they found that there's actually no evidence of any strain found in the rocks that lie in this major fault zone, which means that there was no movement recorded along the fault zone. So then what caused the earthquake? It was later discovered that the earthquake was actually caused by a fault known as the Liogan fault, situated in Liogan, which is not visible on the surface, and this fault was discovered after the earthquake. The Liogan fault is a thrust fault in which the upper block above the fault plane moves up and over the lower block, as you can see in this animation. Generally, earthquakes caused by the thrust faults are more likely to cause significant damage compared to those caused by strike-slip faults due to large vertical movements associated with thrust faults. However, the specific characteristics of the fault, including its geometry, depth, and orientation, can all affect the severity of the shaking and the resulting damage. Now, active faults in general cause tremendous damage due to a mechanism known as fault linkage, where active faults cause the movement in the faults that are not active. Just imagine for a second what would happen if the EPG fault zone was triggered because of the Liogan fault. The casualties would be significantly higher and the neighboring countries would also be affected. And it may also trigger a tsunami. One of the most devastating effects of the ongoing earthquake is a mechanism known as liquefaction, where the water pressure under the sediments rises because of the intensity of the earthquake, which makes the sediment surface behave like a liquid. This causes severe shaking and weakening in the foundation of buildings, and thus they collapse like house of cards. The reason why Haiti earthquake was so devastating is because of a lot of other factors besides the earthquake. For example, the lack of earthquake-resistant infrastructure and the overall how the disaster was managed. There was also an article that mentioned that Haiti did not have a functioning seismic station, which obviously would have had an impact on the overall warning system. Now, is any earthquake really predictable? No. Unfortunately, we still cannot predict when an earthquake will strike. However, we can be better prepared for the future earthquakes by installing better monitoring systems, having an earthquake-resistant foundation for the buildings, and an improvised disaster management and evacuation plan. A lot of these measures are in control of the respective governments and the overall politics that's involved, which I don't even want to get into. But if every country focuses on these aspects that I've mentioned, it would surely help in reducing significant casualties. If you like this video and would like to learn more, then please like this video, share it, and subscribe. It would mean the world to me. Thank you so much for watching, and see you in the next one.